Good morning, students. Myself, Dr. Ashim from Department of Physics, SS College, Hailakandi. I, on behalf of the department, welcome all of you in these online classes. As we all know about the current pandemic situation due to coronavirus, we are not in a position to take physical classes. So we have no alternative other than online classes. Dear students, today I am going to discuss about the atomic and nuclear physics chapter of your syllabus. I will give a brief discussion about atoms and nucleus today. So, first of all, what is atom? We all know about atoms and molecules, probably from class 7 onwards. What we have learned about atom is the smallest part of a substance which cannot be subdivided further. But is it absolutely right or something wrong? Because atom consists of protons, neutrons and electrons. That is, atom can be subdivided. But if we divide atom into proton, electrons, etc., then it loses its chemical characteristics. That is, if we consider hydrogen atom, then after subdivision, it will no longer remain hydrogen but becomes protons and electrons, which doesn't have the characteristics of hydrogen. Moreover, the protons, electrons, neutrons from different atoms have identical character. That is, an electron or proton from a gas, liquid or solid are identical in nature. We cannot distinguish an electron from a gas from another electron from a solid or liquid. So, I think it is clear that if we divide an atom further, it loses its identity. Thus, we can define atom as atom is the smallest particle of an element that can exist with its chemical properties. It consists of protons, neutrons and electrons. The very concept of atom, the very name atom was termed by Democritus about 4000 BC. But the experimental proof of atom was obtained much later, that is about 18th century. Now, what is a molecule? Molecule composed of two or more atoms of same or different atoms. But if we break a molecule into atoms, it does not show the characteristics of molecules. For example, if you consider water molecule H2O and carbon dioxide molecule CO2 and break them into individual atoms, then we cannot distinguish oxygen atom which one is from carbon dioxide and which one is from H2O molecule. So, a molecule consists of two or more atoms of the same element or different elements that are chemically bound together, but it is the smallest particle of a compound that can exist with its chemical characteristics. If we divide a molecule into atoms, it loses the characteristics of molecule. The first model regarding atom is given by Dalton in the 18th century. According to Dalton's atomic model, each element is composed of extremely small particles called atoms. That is, everything in this universe is composed of fundamental particles called atoms. All atoms of a given element are identical. For example, if we consider oxygen gas, then all the atoms of oxygen gas should have identical character. But different atoms from different gases are different. For example, if we take oxygen and hydrogen, the atom from oxygen and atom from hydrogen will be different. That is, atoms of one element are different from atoms of another element. Compounds are formed when atoms of more than one kind combine. That means, by the combination of atoms, we can form molecule, and from molecule we get compounds. Next is Thomson Plum pudding model. So after Dalton's model, Thomson discovered electron from his famous cathode ray experiment, and later Millikan discovered the charge of the electron. It was found that the electron is negatively charged particle. That is, Thomson determined that atoms contain negative particles called electron. However, since the atoms are electrically neutral, so in order to make the atom neutral, there must be equal amount of positive charges also. So Thomson suggested that the electrons in an atom are embedded in a positively charged diffuse sphere-like plum in the pudding, just like the figure as shown. Next one is Rutherford atomic model. Before going to Rutherford atomic model, we have to discuss about the Rutherford gold foil experiment. Dear students, perhaps all of you learned in HS first year about Rutherford's gold foil experiment, in which it was observed that the most of the alpha particles are passes through the atoms without any deviation, and a few of them return back, and few of them deflected from the central part. So, based on the observation from his famous gold foil experiment, Rutherford proposed that the positively charged particles and most of the mass of an atom was concentrated in an extremely small volume of the atom called as a nucleus. We will discuss on the next slide how we can say that nucleus is positively charged. Next, he also proposed that the negatively charged electrons surround the nucleus of an atom, which revolve around it with a very high speed in circular pulse called orbits. Since electrons are negatively charged particles and nucleus are dense concentrated masses of positively charged particles, they are bound together by electrostatic force of attraction, like planets bound to the sun by gravitational force. Now, how can we say that the nucleus is massive in nature and all the positive charges are embedded in within the nucleus? Since few of the alpha particles are deflected from the central part of the atom and alpha particles are being positively charged, and according to Coulomb's law, positive charge and positive charge repels each other. From this, we can conclude that the central part of the nucleus is positive in nature. But how can we confirm that the total mass of the atom is concentrated at the center, that is within the nucleus? For this, we have to take the help of elastic collision. We have to consider the collision between the alpha particle and the nucleus. We all know from HS first year's knowledge that the expression for final velocities of particles executing elastic collisions are: this is the velocity of the first particle after collision, v1, this is the given expression, and v2 is the velocity of the second particle after collision. Now, if a light object collides with a much heavier target which is at rest, then m1 very less than m2 and u2 is equal to 0, like the alpha particle and nucleus. Here the atom is almost at rest, so u2 is equal to 0. Now what happens and what will be the velocities using this condition? It is observed that if we consider m1 very much less than m2 and u2 is equal to 0, then from first equation it is observed that u2 is 0, so twice m2 u2 term will vanish and m1 is neglected with respect to m2, so m1 is also neglected with comparison with the m2, so it becomes v1 is equal to minus m2 u1 divided by m2 as m1 is neglected. So after cancellation, v1 becomes equal to minus u1 and v2 is equal to 0. Since u2 is equal to 0 and m1 is negligible corresponding to m2, something divided by very heavy thing, very much larger thing is approximated, can be approximated to 0. So v2 is 0. From this expression, we can take inference from the Goldfold experiment that v1 is nothing but the velocity of the rebound back alpha particles, which is equal to the velocity of the alpha particles incident on the atom, that is v1 is equal to minus u1. This condition is satisfied by the alpha particle. That's why we can say that the nucleus, the central part of the atom, that is nucleus, is much more heavier than the alpha particle using this condition. Now, what are the limitations of Rutherford atomic model? Rutherford model could not explain the stability of an atom. Now we have to discuss what is the stability of atom and how stability is not maintained in Rutherford experiment, Rutherford atomic model. From Rutherford model, we observe that the electrons are moving around the nucleus in circular orbits, and we also know that circular motion is an accelerated motion because the velocity is changing continuously. But according to Maxwell's, an accelerated particle radiates energy. So, since the electron is circulating in a circular path, it also radiates energy, and a part of its energy loses in the form of electromagnetic wave. As a result, the radius of the circular orbit will goes on decreasing, and finally it will collapse to the nucleus according to Rutherford model. That's why it cannot explain the stability or existence of, it cannot explain the existence of atom. This model did not say anything about the arrangement of electrons in an atom, which made this theory incomplete. Here, the location of electron within the atom is not at all described by Rutherford model, as if the electrons are continuous around the atom. This picture shows how the electrons radiates energy and finally collapse to the nucleus. So Rutherford's model, atomic model, fails to explain, and we need a new model to explain the atom. Before going to new model, another important discovery taken place, that was Chadwick discovery of neutron. By this time, the mass of protons and electrons were detected, and also we can measure the mass of atom. It has been observed that the mass of an atom is greater than the mass of its protons and electrons. Therefore, from the conservation of mass, there must be another particle in the atom that has mass. Otherwise, conservation of mass will not satisfy. This additional particle must not have any charge, because charge conservation is already maintained in Rutherford model. If the new particle had charge, then the atom would no longer be electrically neutral. So the new particle must not have any charge. Chadwick in 1932 confirmed the existence of these particles, which are called neutrons. So atom consists of three particles. One is proton, positively charged, another is electron, negatively charged, and third one is neutron, which is chargeless. Now, next model of atom is Bohr atomic model. Neil Bohr proposed that electrons revolve around the central positive nucleus like planets in the solar system. The planets moves around the solar system by gravitational force. Here, the electrons move around the nucleus by electrostatic force, rather Coulomb force. The electron is able to revolve in certain stable orbits called stationary orbits around the nucleus without radiating any energy. We have already observed in Rutherford model that electrons are radiating energy, that's why they ultimately collapse to nucleus. So in this model, this hurdle is overcome. Here it is mentioned that the atoms can only gain and lose energy by jumping from one allowed orbit to another, absorbing or emitting electromagnetic radiation with a frequency determined by Planck's relation. That means what we have learned from Rutherford model that electrons emits energy continuously, but according to Bohr model, electrons cannot emit it continuously, or electron cannot emit continuously or absorb continuously, but it can emit or absorb energy only after jumping from one orbit to another orbit. Now, what are the limitations? Bohr's model is also not perfect one. There are several limitations of Bohr atomic model. The first one is it is valid only for one electron system like hydrogen, helium plus, etc. It cannot explain the complex atoms. Number 2, orbits were taken as circular, but according to Sommerfeld, these are elliptical, like planetary motion. Next one is intensity of spectral lines could not be explained. Spectral intensity of energy cannot be explained by Bohr's atomic model. Next one is nucleus was taken as stationary, but it also rotates on its own axis. In Bohr model, nucleus is taken as stationary, central part is stationary, but it is not at all stationary. Everything in this universe is in motion. It could not be explained the minute structure in spectral line, that is fine structure of atoms cannot be explained by Bohr atomic model. This does not explain the Zeeman effect, the splitting up of spectral lines due to magnetic field, and Stark effect, the splitting up of spectral lines due to electric field. So there are lots of limitations of Bohr atomic model. So this model is not also perfect one. These limitations can be explained and overcome by quantum model, and which is beyond your syllabus. So I am not going to discuss the quantum model of atom. By quantum model of atom, we can discuss completely the atomic state of substance. Thank you very much. If you have any query, you can